Welcome to this video tutorial from spssvideotutor.com. I'm Jacob Mays, and today I'm going to demonstrate how to perform and interpret a chi-square test for independence. In this demonstration, we will examine if there is a relationship between taking part in a rehabilitation program for first-time criminals and second arrest. Participation in the rehabilitation program is our first categorical variable, and it contains two categories. Yes, you participated in the rehabilitation program, and no, you did not participate in the rehabilitation program. Second arrest is our second categorical variable. It also contains two categories. Yes, you were arrested a second time. No, you were not arrested a second time. Because each of these variables has two categories, this is considered a 2x2 design. In order to perform the chi-square test of independence, we go to Analyze, we go to Descriptives, then we go to Crosstabs. Next, we select our first categorical variable, which is rehab, and we move it into the rows box. Then we select our second categorical variable, which is second arrest, arrest 2, and we put that in the columns box. We then go to statistics, select chi-square and phi and Kramer's V, and then we click continue. Then we click on the cells button. We check expected, observed should be checked. Then we select rows, columns, and total percentages. We click continue, and then if you're pasting it to your syntax file, you click paste. If not, you click OK. Now, the first table that we see is the case processing summary table. Okay, this tells us the number of respondents that are included in our analysis and the number of missing cases. So we have 1,000 people who have been included in this analysis, and there are no missing cases. The second table is our crosstabs table. Each cell contains the count for that cell, expected count, row percentage, column percentage, and percent of total of all cells. Okay, so for example, in the first cell we see that there are 210 people who did not partake in the rehabilitation program and who were not arrested a second time. The expected number for this cell is 243.9. The row percent is 30.4, so this corresponds with the row. So 30.4% of respondents who did not participate in the rehabilitation program were arrested, and 69.6% were arrested who did not participate in the rehabilitation program. The next number is the column percent, which is 59.5. So 59.5% of respondents were not arrested a second time and did not participate in the rehabilitation program, and 40.5 were not arrested and did participate in the rehabilitation program. Okay, and the final number is the total percent. So this number, this number, this number, and this number in the total all equal 100. Okay, now if we go down to the chi-square test table, the first thing we want to look at are the footnotes. Okay, here you check to see if you have violated the assumption of the chi-square. The assumption is that the minimum expected cell frequency for each cell should be 5 or greater, or put another way, at least 80% of the cells have expected frequencies of 5 or more. Okay? So if this number is greater than 20%, this assumption has been violated. So if it's greater than 20%, you need to either gather more data or, if possible, collapse your cells into larger groups using the recode procedure to create higher counts in each cell. Okay? Now, once you've determined that you have not violated the assumption, if you have a 2x2 design, which we have here, you look at the data in the second row labeled continuity correction. Okay? If either of your variables has 3 or more categories, then you look at the first row labeled Pearson chi-square. Okay? So for example, if we replaced the variable participation in the rehabilitation program with region, which has 3 categories, north, south, and west, we would look at the Pearson chi-square. Okay? But in our case, since it's a 2x2 design, we're going to look at the continuity correction. Now, in either case, if the value of the asymptotic significance two-sided is less than 0.05, then there is a statistically significant association between the two variables. Since our significance value is below 0.05, this means that the proportion of rehabilitation participants who were arrested a second time is significantly different than the proportion of non-rehabilitation participants who were arrested a second time. So in order to determine which group actually performed better, those who participated in the rehabilitation program and those who did not participate in the rehabilitation program, we go back to the crosstabs table and we look at the percent within rehabilitated. So always look at the third one from the top. Okay? We see that 30.4% of those who didn't participate in the rehabilitation program were not arrested a second time versus 69.6% that were arrested a second time. Then we compare that to those who did participate in the rehabilitation program. 46.3% were not arrested a second time, and 53.7% were arrested a second time. So, since we know from the chi-squared that these numbers are significantly different, then that means that those who did not participate in the rehabilitation program were more likely to be arrested a second time than those who did participate in the rehabilitation program. Okay? Now, finally, we go to the last table. Okay? This output table contains statistical tests that measure the effect size or strength of the association. Like the correlation coefficient R, they range from 0 to 1, where higher values indicate a stronger relationship between variables. Okay? You want to use the phi statistic when you have a 2x2 design. Okay? You use Kramer's V if either one of your categorical variables has 3 or more categories. Okay? Now you know how to perform and interpret a chi-square test of independence. If you have any questions, please submit them to jacob@spssvideotutor.com. This has been a video tutorial from spssvideotutor.com. Thank you for watching and much success with SPSS.